This cello is made of carbon fiber instead of traditional wood. Enthusiasts believe this newer carbon version has a more powerful sound than the wooden instrument. It still has that characteristic sweetness, but it's more likely to be heard in the orchestral din. And after all, every musician wants to be heard. The carbon cello is the masterstroke of a Boston Symphony cellist who noticed waves resonate loudly against carbon fiber boats. They cut the top piece of the cello out of fabric that's woven with carbon strands. This material is stronger than steel, yet electric shears easily cut through it. A worker cuts out numerous top cello pieces and then sets them aside while he works on another section of the instrument. He brushes special resin onto a fiberglass mold of the cello's back, ribs, and neck. The mold has been pre-waxed to keep the resin from sticking to it. The idea is to saturate this big piece of carbon fabric with the resin as he tucks it into the curves of the mold. He smooths it down to get rid of any bubbles that could affect the cello's tone. He brushes more resin onto the other side of the fabric, making sure it gets into all the crevices. He sponges away any surplus. And then layers more fabric and resin as he builds a laminated carbon fiber shape. He covers the layers with nylon-like material and trims the edges of the carbon fabric. Next, he places perforated plastic on the nylon and piles absorbent batting on top of that. He installs a vacuum pump and drapes a big plastic vacuum bag over everything. Then activates the vacuum. It sucks out the air and any excess resin. The perforated plastic controls the amount and the batting absorbs it. While it's still under vacuum, they put the whole thing in an oven to bake the carbon fiber layers together. After they peel away the batting and plastic, it comes out looking like this. The plies have fused together and the shell has a sleek look to it. They laminate the cello's top piece in a mold and bake it until it's also hard. Using a bandsaw, they trim off the ragged edges and sand them for a smooth finish. Now they clamp the cello top piece onto a fixture that has stencils on the back. With a router, they cut out the stencil shape. The sound will eventually emanate from these F-holes, as they're called. They attach the company label with glue to the inside of the cello's back section. Then they glue around the top inner rim of the cello. They tape the back tightly in place while it hardens. Next, they glue the laminated carbon fingerboard to the neck of the cello. They drill holes into the peg box and insert the pegs, which are used to tighten the strings. Soon, this cello will be more than just a shell. Coming up, they raise the curtain on its inner workings. The story of this cello has many layers. They're all carbon, and now the layers have hardened into the shape of a concert instrument. At this point, you can't make music with it, though, because they have yet to construct the inner workings. A process that is, in itself, a carefully orchestrated performance. The cello frames need a bit of body work. They rough them up with sandpaper. Then spray on a polyurethane clear coat to protect the surface. Then it's over to the string specialist called a luthier. He sets a roughly cut wooden bridge on top of the cello and takes measure of the position. The placement of this bridge needs to be exact because its job is to elevate the strings and transfer their vibrations to the instrument. If its position is a bit off, the cello's sound will also be a bit off. Using a grease pencil, he maps out the position of the bridge between the F-holes, then sets it aside. Now he slips the wooden sound post into one of the F-holes and wedges it between the front and the back of the cello. The sound post is crucial. It'll strengthen the cello and couple the strings' vibrations between the front and back of the instrument. This is delicate and highly skilled work. He measures to determine if the sound post is on the mark. If it's off even by a millimeter, he adjusts it a bit more. Afterwards, he double-checks the bridge's positioning. Then, with a red grease pencil, he colors over the spots where the feet of the bridge are to sit. He presses the bridge's feet into the grease marks, and this makes red smears on the feet. The smears tell him where to shave the wood so that it will fit perfectly on top of the cello. The bridge doesn't get glued down. It's held in place only by the pressure of the strings. Next, he makes pencil marks on both tips of a measuring stick. He leans the stick against the bridge at the same angle as the strings that will run over it. He then transfers the pencil marks from the stick to the top of the bridge. He rounds off the marks by penciling around a template. And then he carves the bridge down to size. He planes it down to make it thinner. With a file, he cuts grooves to cradle the strings. Now he moves to the bottom of the instrument and slides a spike called an end pin into a pre-cut hole. The end pin will rest on the floor, steadying the cello. He lassos the end pin with plastic rope, which is attached to the tailpiece. And he rests the tailpiece on the belly of the cello. He pulls the steel strings from the pegs and hooks them onto the tailpiece. Like most classical string instruments, the cello has 4 strings. Now he slides the strings into the grooves on the bridge. He turns the pegs to tighten the strings. The strings push down on the bridge, holding it in place. He tunes the cello, and now it's ready for a full-scale performance.